Proteins and polypeptides are biopolymers that consist of linear chains of amino acids. The amide or peptide link is the characteristic functional group that recurs along the peptide chain. The amino acids differ in the nature of the R groups attached to the alpha carbon atoms, as we will see later. The primary structure of a protein or polypeptide is the linear sequence of amino acids linked by the peptide bonds. A1, A2, and so on represent distinct amino acids, differing in the side group. All organisms use the same 20 amino acids as building blocks. The shape taken up by the chain of amino acids in a protein is called the secondary structure. The secondary structure is governed to a large extent by a hydrogen bonding between segments of the chain. This bonding often leads to a spiral structure known as alpha helix. The hydrogen bonds form between adjacent amino acids along the chain, for example, between acids A3 and A7. Hydrogen atoms bound to the amino nitrogen atoms form hydrogen bonds to carbonyl oxygen atoms. Now let's examine the amino acids, the building blocks of proteins and polypeptides. This shows the amino acid in its neutral or unionized form. However, because the amino group nitrogen is a good base, the proton of the carboxylic acid is transferred to the amino group, forming a Zwitter ion. Near neutral pH conditions in solution, and in the solid state, amino acids exist as Zwitter ions. Here are 3 examples of the 20 amino acids that are most commonly found in living organisms. Notice that the central carbon atom in these acids has 4 different groups attached to it. This means that all the amino acids other than glycine, for which the side group is H, are chiral molecules. They are not superimposable on their mirror image, as shown here for alanine. In nature, the amino acids are found in only one of the 2 possible enantiomeric forms labeled L for the direction in which solutions of amino acids rotate the plane of polarized light.